Good day everyone, welcome back to my channel. Today we are looking at equations and inequalities, solving simultaneous equations algebraically. And we are to solve for both x and y respectively. Given the nature of the linear equations or system of equations are as follow: x plus 2y is equals to 5 and x minus y is equals to -1. It's important to take into account when working with simultaneous equations that the graphical method of solving systems of equations has a number of disadvantages. It can give inaccurate answers if the graphs are not accurate. Solving equations by substituting different values of x and y is very tedious and time-consuming. Systems of equations can be solved algebraically. Now, at this stage, in virtue of this application, it's very important to approach this by having an understanding that all lines follow the following equation: y is equals to mx plus c. Now we talk about linear equations. Now, in this insert, we are given a system of equations: x plus 2y is equals to 5, and x minus y is equals to -1. Technically, what I know here is that I have equation 1 and I have equation 2. I have two equations. Now, in essence, in order for one to solve simultaneous equations, it's important to understand that one can actually choose one of the two key principles relating to solving simultaneous equations, known as the substitution method and the elimination method. Let's start with the substitution method. The substitution method is whereby one substitutes a variable, or rather a series of variables, into one equation to find the outcome. Let's see how this applies. Now, I need to convert one of these equations into a new equation. So I'll simply use equation 2 since I have 1 as a leading coefficient. Now, and also make x the subject of the formula. This will apply as follows: x is equals to -1 plus y, and this is our new equation 2, which is the same as this equation there. Now, what I want to do with this new equation 2 is to substitute that equation into the first equation. So essentially, we substitute equation, or rather new equation 2 into equation 1. And this applies as follows. Where x is, I'll just open the parenthesis and I'll just simply have plus 2y, which is there, is equals to 5. Now, with substitution, looking at this application, I have where x is, I just simply substitute -1 plus y. Now that I've substituted negative 1 plus y, where x is, I can just simply start using the distributive law to open the parentheses by multiplying 1 by negative 1 into the parentheses and multiplying positive 1 by positive 1y. And this applies as follows. 1 multiplied by negative 1 will just simply give us 1. 1 multiplied by positive 1y will give us positive y plus 2y is equals to 5. Now that I've opened the parentheses, I can start collecting the like terms. I have 1, oh, this is negative 1 because positive multiplied by negative gives us negative. And hence also I have negative 1. So positive 1y plus positive 2y will give us positive 3y is equals to 5. With further calculations, I have 3y is equals to 5 plus 1. Notice this one here will move over. It's negative, and if it moves over, it becomes positive 1. Hence, plus 1. So we have 3y is equals to 6. Divide both sides by 3 and 3. The 3 will cancel out, and I'll only simply remain with our variable of y. And then 6 divided by 3 gives us 2. Now the value of y is simply 2. Now that I found the value of y, I can start substituting the value of y in either one of these two equations, either equation 2 or equation 1, to verify and check whether this satisfies our answer. By doing that, we can start with equation 1. So equation 1, we have x plus 2y is equals to 5. So where x is, where y is, we substitute 2. X plus 2 times 2 is equals to 5. X plus 4 is equals to 5. X is equals to 5 minus 4. X is equals to 1. I also found the value of x, which is equals to 1. With further calculations and verifying this application, we can just simply carry out further calculations relating to the system of equations. X plus 2y is equals to 5. We know that our x is 1 plus 2 times 2 is equals to 5. 1 plus 4 gives us 5. And that consolidates our first insert of the first equation. And then we need to find whether, or determine whether this also satisfies our second equation. With further calculations, that was the first equation, equation 1. Let's see what happens when we substitute x and y in our second equation. X minus y is equals to negative 1. We discovered that x was equals to 1, so we substitute 1 where x is minus. We also discovered that y is equals to 2, so we substitute 2 where y is equals to -1. So because that answer is correct, that satisfies our second equation. Which is equation 2. So that was our application relating to substitution method. Now, our second application of solving simultaneous equations is known as the elimination method. And let's see how this applies in algebra. Now, the same system of equations are given. So we have x is equals to 2y is equals to 5. X minus y is equals to -1. We know that the first equation, just fixing the pen. Pardon about that. So first equation is 1. This is our second equation. This is equation 2 rather. Equation 1, equation 2. Now, this application relates to the elimination method. Now, how the elimination method works is to find the difference between the two systems of equations. First equation, we want to have equation 1 and subtract equation 2 from equation 1 and equate that to equals to 0 because we are working with multiple variables. With calculations, we have x plus 2y is equals to 5. That's equation 1. And then place that in the bracket, subtract, open bracket, x minus y is equals to -1. And equate this to 0. Now notice here what I have is an equal sign. I also have an equal sign and I have an equal sign there. I want to remain with one equal sign in this application. By doing that, I need to place these terms in the right order. So x plus 2y minus 5 is more applicable in algebra, minus x minus y plus 1 is equals to 0. And that looks much elegant and more applicable in algebra. Since because it's not correct to be leaving variables and constants lying around in when you carry out your calculations. It's always best practice to tidy them by using braces. Now, in this instance, that is more applicable. Now, I need to open the parentheses in our next step. So it's to basically distribute 1 into the parentheses to open the brackets. 1 times x gives us x. 1 times positive 2y gives us positive 2y. 1 times -5 gives us -5. -1 times x gives us -x. -1 times -1y gives us positive y. -1 times positive 1 gives us -1 is equals to 0. So that the parentheses are open. So the next step is to start now collecting the like terms. X and X will cancel out because X subtract X is 0. And then positive 2y plus 1y gives us 3y. Negative 5 minus 1 gives us negative 6. All in all is equals to 0. 3y is equals to 0. Notice negative 6 is negative on the left hand side. If it moves over, it becomes positive 6. And then divide on both sides by 3. 3 will cancel out, and you remain with y to be equals to 2. Same answer that we found in the application of substitution. So we can also test and verify this variable if it's true. So we can substitute that into our second equation or either in a first equation, either way. So with further calculations, x plus 2y is equals to 5. X plus 2 times 2 is equals to 5. X plus 4 is equals to 5. X is equals to 5 minus 4. X is equals to 1. And once again, we found x to be equals to 1. And because the answer yields the same answer, or should yield the same answer as we found or discovered in the first application when we used the substitution method.
It's 20 hours.
And then we can now start inferring or concluding on the basis of this observation to say that x is equals to 1 and y is equals to 2. And that brings us to the end of our simultaneous equations using both the substitution method and the elimination method. Thank you for watching. Please don't forget to share, like, and subscribe to my channel. And don't forget to drop the comments in the box below. Don't forget to practice mathematics and enjoy mathematics. Have fun. Thank you. Goodbye.